is important. Whether we're talking about organizations or nations, the use and abuse of power has a profound effect on people's lives, from personal satisfaction to our ability to govern a nation and reach collective goals. Liz Johnson and I set out to develop a deeper understanding of power, and we succeeded by using an innovative methodology. Integrative Propositional Analysis, or IPA, is based on insights from systems thinking and cybernetics because, like an organizational system, we can look at theory as a conceptual system of things and their connections. For our purpose, those things are measurable concepts and the connections are the causal relationships between them. This helps us to synthesize and improve our theories. Phase 1 of IPA is to identify the propositions in the theory and create a causal knowledge map. Phase 2 involves the evaluation of the systemic structure. For a simplistic example of synthesis, consider two theories: things in boxes, arrows, or causal relationships. By synthesizing them, we can more easily identify features such as feedback loops where none existed in either of the original theories. Using IPA, we can show that theories that have more complex and interconnected parts are more systemic and are more useful in practical application for understanding a situation and reaching goals. Here we have the systemic structure on the vertical scale, and theories of physics and laws of physics and engineering models are up at the top, and theories of the social sciences are down towards the bottom. On the horizontal scale, we have simple complexity, just the number of concepts within each theory. The data for our study came from a chapter written by Professor Dr. Gerhard Fink. He had 4 theories of power, and let me tell you, that's a lot of text. So in phase 1, we created these 4 diagrams. Okay, they're way too small to read here, but take a moment and look at the structure, the things and the connections. Notice how many of the concepts have few causal connections. If the people and departments of your organizations were that fragmented, they wouldn't get much done. In fact, it's kind of nonsensical, hardly an organization at all. Phase 2 of the analysis was using IPA to calculate the structure, and here those results are shown according to their simple complexity and systemic structure, and they are in the lower left-hand quadrant. The low level of structure indicates a low probability that people could use these theories to take effective action to improve their organizations. We took 2 more major steps in this analysis. First, synthesizing the theories, and second, interviewing Dr. Fink to add additional insights that were not included in the published theories. Key here is that by rigorously synthesizing theories, we improved the systemic structure, thus making them more useful for practical application. We also identified a core of more useful knowledge and a belt of less connected concepts which are more useful for conducting research. That's where we'll find the quickest advance in research. An additional and ongoing challenge for scholars is how to make better computer models. As in this simulated soccer match. I guess just to tie it in, it's power soccer. This paper suggests that we will be able to make better simulations if we have more systemic maps. See the paper for a lot of good, helpful tips in that direction. So this paper emerged from a challenge, and we rose to that challenge, both evaluating and improving our understanding of power systems. We now challenge you to read this paper and engage the material to create better theories and to use those theories in the creation of better models and simulations. Thank you.